Only the Voyager 1 and Voyager 2 probes have so far reached the great void beyond the borders of our solar system. Voyager 1 encountered 300 unknown objects there, which caused fright and panic among scientists. What exactly were these objects, and why are they such a threat to us? Stay tuned for everything you need to know about this discovery and get ready for a journey far beyond the boundaries of the known. Billions of miles from home, NASA's Voyager 1 spacecraft has completed a milestone in space exploration. In 2012, it became the first spacecraft in history to reach interstellar space. Never before did scientists and engineers think they would see this happen when they sent Voyager 1 and its twin probe, Voyager 2, on their way in 1977. The mission of the probes was designed to last only a few years, and now they have been flying inexorably through the cosmos for 45 years. Last year, something strange happened. Voyager 1 had already been flying for 10 years over the threshold of the heliopause when a particle stream reached the measuring sensors exactly where it should not have been. More than 300 unknown forms of particles were measured, and scientists were shocked. There shouldn't actually be much in open space. Particle density decreases dramatically in interstellar space. The strange stream resembled a veritable bombardment. This fact was surprising and fascinating at the same time. Particle streams always indicate forces, but the measurement data did not make sense at first. It was speculated that we were on the verge of discovering a new elementary force, and it could change our world forever. To understand how important the processes at the edge of our solar system are, we must first illuminate what exactly interstellar space is in relation to our solar system. The heliosphere, our home, is not an immobile place. Our sun is a powerhouse, racing through the galaxy at about 725,000 kilometers per hour. Plasma streams originating from the outer region of the sun spread out along invisible lines and spread evenly, like a ball or sphere, around the sun and its planets. This protective force field is the heliosphere. Without the currents from the sun, we would know no heat and no life. But as we all understand, the particle streams can also be dangerous. Violent solar winds have the ability to briefly disable or irritate our entire electromagnetic network in such a way that, for example, power supplies or telecommunications could collapse. If we look into the cosmic context, however, these plasma flows from the sun are more protective than dangerous. From outside, from interstellar space, we are threatened by radiation and strong magnetic fields. These forces and currents of fine particles are relics from the early times of our universe. Until today, these currents and forces are still present in the space between the stars, and they interact everywhere they meet other forces or celestial bodies. At the edge of our solar system, there is a clash of interstellar forces with those of our sun. The discovery of the new particles is, therefore, in several respects, a surprise and, at the same time, possibly also a threat. Of course, it's not to be expected that the heliosphere will abandon us, but we still know far too little about the processes far out in space to be able to be sure that there is no danger from there. The exploration of the plasmas that fill interstellar space, as well as the outskirts of our solar system, was an astronomical first. The researchers were very fortunate that Voyager 1 and 2 reached the boundaries of the heliosphere, passed through the heliopause, and finally entered the fringes of interstellar space at completely different times and places. In this way, scientists were able to compare valuable data. The measurement results of the two space probes show numerous similarities. For example, the density of the particles they measured in interstellar space. Excitingly, however, both probes also discovered significant differences that raise new questions about how our sun moves through the galaxy. Just like oil and water, solar winds and the interstellar medium do not mix homogeneously. At the very edge of the heliosphere, called the heliopause, interstellar space begins. Measurement data from this boundary bring us more knowledge about how the sun moves through interstellar space within the galaxy and what changes we should expect as a result of these movements. Scientists were first able to explore these unknown regions on August 25, 2012. That's when Voyager 1 entered interstellar space. Even then, the measurement data were shocking. The interstellar magnetic field proved to be 2 to 3 times stronger than expected. This, in turn, means that the interstellar particles exert up to 10 times more pressure on our heliosphere than previously suspected. On the other side of the boundary, the interstellar medium is nearly 30,000 degrees hotter than expected. Now, you're probably wondering how two simple probes can survive such temperatures. Well, that's easy. The hot plasma is so thin and diffuse that the average temperature around the Voyager probes is remarkably low. Heat, like sound, can only be transported by particles. Extremely charged particle streams, however, could become a hazard to the probes if they occur more frequently and in high density. No one expected these extreme loads in a room where there really shouldn't be much. Precisely because the measurement data were so sensational, scientists naturally wished that Voyager 1 and 2 would continue to send data to Earth for a while. An interstellar follow-up mission would need decades to reach exactly where the two Voyager probes are today. Although other space probes are currently on their way out of the solar system, they will not be able to send data from the heliopause. NASA's New Horizons probe is moving through the solar system at more than 50,000 miles per hour. However, New Horizons is nowhere near as equipped with powerful batteries as the Voyager twins. When it runs out of power in the 2030s, the data stream will also dry up. So all eyes are still on the Voyager mission, and engineers are doing everything they can to keep the two veterans fit. A large part of the measurement equipment has already been switched off to save power. Only the magnetometers and the plasma meters are currently still active around the clock. Meanwhile, the data takes more than 20 hours to reach Earth, and it can only be captured by 3 extremely powerful antennas spread across the globe. Great concern erupted when Voyager 1 appeared to have completely lost its bearings. Was Voyager 1 under fire from unknown forces, or what could be responsible for the disorientation? Interestingly, none of the probe's protection systems had been triggered, indicating that it was not an external threat. But then what could have messed up the telemetry data? The only way to find out for sure was through extensive troubleshooting. List after list of potential factors were worked through. NASA's research team went through all the systems on the more than 40-year-old spacecraft. Old blueprints were dug up for the first time since the spacecraft's launch, and there was near panic at NASA for days. Losing Voyager 1 at this important point in its mission would have been a disaster. All possibilities of the effects of cosmic rays on electronic components and the possibility of temperature fluctuations were examined in relation to the stability of the sensitive instruments. The team examined communication systems, trying to rule out potential signal interference from cosmic noise or other disruptive factors. The search took weeks. After months of receiving jammed data, the scientists and engineers were able to re-establish clear communications with the probe. What had happened? In the official final report, the cause of the problem was traced to Voyager 1's attitude control system, or more precisely, a defect in what should have been an inactive onboard computer. Presumably, this computer surprisingly turned on, although it had actually been deactivated for years. After the source of the problem was discovered, the engineers quickly developed a solution. They sent a signal to Voyager 1 to leave the faulty system and switch to the correct computer. With radio waves taking nearly 22 hours to travel back and forth, the recovery process required extreme coordination and, most importantly, patience. Although NASA remains committed to this reason for the malfunction to this day, some independent scientists indicated that the malfunction was caused by an unknown force. They compared measurement data from Voyager from the zone it was in. According to NASA, there shouldn't have been much in that fringe area, no turbulence and no unusual occurrences. But hadn't the researchers already learned with the measurement data at the transition to interstellar space that their assumptions about the real nature of this zone had been wrong? NASA is optimistic that the error has been corrected once and for all. Voyager 1 will continue its journey and send data into the 2030s. Nevertheless, many mysteries remain, and by no means do all scientists share the same opinion about how to interpret the disturbing measurement data. To solve the mysteries of the structure of our solar system, we need a better overall picture of the heliosphere. Astronomers and cosmologists want to know more about how our solar system moves through the galaxy and space. The fantastic new measurement data show there is still so much more we don't know. That's why another interstellar probe is soon to be launched. The goal is a mission that will last at least 50 years and span several generations, exploring the outer regions of the solar system and venturing into unknown realms beyond the heliosphere. Today's explorers will begin this mission, and their children or grandchildren can then continue the work begun in these days, weeks, and years with a probe designed specifically for flight through interstellar space. Voyager 1 will continue its journey indefinitely. Even after the data stream dries up in several thousand years, the small spacecraft will reach the next star system, and, who knows, maybe someone there will wonder where this strange part came from. Tell us what you think about this extraordinary find. How important is the exploration of the borders of our solar system to you? Do you think there is some kind of danger lurking there?